We're very fortunate in this country to have records for reported meningococcal disease that go back for over a century. And although the definition has changed over the years, the important thing to note about this slide is you can see enormous differences in the incidence of disease at different times. I haven't got a pointer, but you can see the peak of disease in the First World War, here, and then in the Second World War, massive peak of disease. And then you get low levels in the incidence of disease until the late 1980s and 1990s, when we saw the highest rates of meningococcal disease since the Second World War. Just to look at this more closely, Mary's already shown this slide, so I won't dwell on it, but you can see from 1984-85, the number of cases in this country rose from just over 500 to peak at more than 2,600 at the end of the 1990s, and this was obviously great concern. Now, those in pink are serogroup B, those in blue are serogroup C, and you can see that the majority of cases are serogroup B, for which we didn't have a vaccine at that time. But the numbers of cases of group C were alarming, and in 1999, as everybody here knows, the meningococcal C programme was introduced, both in infants with a catch-up programme, and we saw this dramatic reduction in cases of serogroup C. What is also very interesting is that we see this decline in cases of serogroup B, against which there was no vaccination. So though in 2012-13 compared to 98-99, there are 900 fewer cases of group C, but also more than 1,000 fewer cases of serogroup B. And we found this really quite intriguing. What's going on? What's happening? What's the cause of this reduction? And why is it that we see these fluctuations in disease? Now, I think I'm right in saying that the meningococcal C conjugate vaccine was the first vaccine that was introduced without any efficacy studies. And so around that time, although we predicted on the basis of Hib vaccine that it would be very effective, and indeed it was, we didn't know that at the time. And there were concerns about capsule switching or serogroup replacement. And so in 1999, at the time that the vaccine went in, we undertook a large Carriage study to look at the population of meningococci that were circulating at the time, and that was our baseline. This was what was circulating before any vaccine went in. And then we sampled another 18,000 students the following year and the year after that to look at what was happening with the impact of the vaccine on the carriage of meningococci. But you can see there are many, many different clonal complexes that are carried in the back of the throat. Those on the right show those that are invasive clonal complexes, and you can see that there's only just a few of those that are carried that are actually invasive. Now, we know this is partly related to polysaccharide capsule, but there must be other determinants that account for the invasive potential of these carried meningococci, and we want to try and explore those further. What this slide also shows is that the ST11 serogroup C, or these are serogroup C, the bottom two, reduced following vaccination, and this reduction in carriage accounted for the herd immunity that we saw. Mary's already shown this very nice meta-analysis that Hannah undertook, and I want to just show this because the studies that we did back in 1999 to 2001, we undertook in sixth form students aged effectively 17 and 18, although there was a slightly wider age group because in Scotland those last 2 years actually start in the age of 15. And we chose those age groups because of this rapid rise that you see in meningococcal carriage between about 15 and 20. And obviously we wanted to sample groups with high rates of meningococcal carriage. And this is what we found, that with increasing age in our study, we got increasing rates of carriage, such that those who are about 18 had approximately double the odds of carriage of those who are 15, and that's entirely consistent with Hannah's data. What we also showed was that this was related to some of the behaviours that the students were doing, and in particular, the number of kissing contacts, the amount they smoked, and attendance at pubs and clubs. And this graph here shows the impact of those behaviours. So these individuals here are very sad creatures. They don't go to the pub or club, they have nobody to kiss, and they don't smoke. They're very, very well behaved. These people up here are the party animals. they smoke, they're kissing, and they're out at the pub and club at least 3 times a week. So, and the difference in the prevalence of carriage between these people and these people is about 4-fold. So it really does make a difference. Now, in between these different lines, these are the people who go to a pub and club, but they don't do anything else. These ones are those that kiss, and they go to a pub and club, but they don't smoke. These ones smoke but don't kiss, and these ones smoke and kiss, and they're very, very gregarious. And what's interesting is that once you adjust for these factors, the effect of age goes away. So it's not that they're getting older that makes the difference in the prevalence of carriage, it's what they're actually doing. So the questions, so that's really by way of background, really, is why we did this study. So the questions we wanted to ask was, why is there such a high instance of disease in the mid-1980s to 2000s? Why is it reduced? And what's going to happen next? So last year, we undertook a study to sample between 14 and 18,000 sixth form students, really to repeat those studies that we did in the late 1990s. And what we wanted to do was to complete this box at the bottom. We wanted to be able to compare carriage and disease isolates at times of high incidence and low incidence of disease. We're now in a time of very low incidence, really. In the 1990s, we had a high incidence. We have carriage and disease isolates from that time, and we wanted to be able to get a sample of carriage isolates from this period of low incidence of disease. And we're very grateful to Ray and the Public Health Laboratory, who have such a valuable collection of disease isolates that goes back many years, and that they're willing to share those isolates so that this study could be undertaken. And we also wanted to investigate the risk factors for carriage, and in particular whether there are changes in social behaviour amongst this group of teenagers with respect to smoking, kissing and socialising, because our impression is that there's less smoking and there's probably less socialising because more is done digitally now. So there may be less personal contact, and clubs aren't quite the smoky places that they were in the late 1990s, and that might have an impact. So the design was a multi-centre cross-sectional survey of meningococcal carriage with a questionnaire. It was a very, very simple concept. What we wanted to do was take an oropharyngeal swab from the back of the throat. Now everybody knows this is the home of the meningococcus. The human is the only known host, and this is where it likes to live. We'd asked students to complete a 1-page questionnaire, but the challenge was the numbers. And when you're trying to deal with this many numbers, as my son said to me, "Mum, you do realise that's a very large number," and it is. We wanted to make this as similar as possible to the studies that we did before, despite the fact that there is really a slightly different research climate now. We wanted to use the same centres, the same age group, the same time of year, the same microbiological methods and the same risk factors so that it was comparable to those studies from 15 years ago. Now these are the sites that we used. So 15 years ago we used all these sites in blue: Glasgow, Stockport, Cardiff, Oxford, London, Plymouth, and we also used Nottingham. Now Nottingham weren't able to commit to this study this time, and the situation in Wales had changed. So previously there were 2 sites in Wales, Cardiff and Bangor, but the lab had moved from Bangor, and for various reasons it was decided that all the sampling would be done in Cardiff. Bristol were willing to take the place of Nottingham, and so that was a new site. And then these other sites, Maidstone and Tunbridge Wells, Manchester, Wigan and Preston, were actually CRNs who approached us and said, "Can we take part in the study?" And given that we wanted to make sure that we secured our numbers, we said, "Yes, please, thank you very much." We used exactly the same age group as we previously, the same sixth form students, years 12 and 13, S5 and 6 in Scotland, so students are aged between 15 and 19. We aimed to do it at the same time of year, but there were constraints, as Mary's mentioned, because of the flu vaccination campaign. Some people were not able to commit to the original time period between October and December, which is what we used before. We wanted to keep it to approximately the same season, so we agreed that between September and March would be acceptable as a kind of winter sampling period. We wanted to use the same microbiological methods, but in fact these have changed. So previously we either took the swab and plated it directly on site, or we took the swab back to the lab and indirectly plated it at the lab. Now, some of the machinery is semi-automated, and you plate out a broth, which is a different method. And also in Bristol, they've developed a method of freezing the sample and actually analysing it later, which makes it much easier in the lab. So we do have a wider range of microbiological methods. We also looked at largely the same risk factors, although we dropped some that weren't shown to be of any interest, namely deprivation and crowding. And we wanted to look more at the effect of smoking, and including passive smoking inside and outside the house, and also the use of water pipes and shisha pipes, and asking a bit more about boyfriends, girlfriends, whether or not they smoke, and also their ethnic group, which we didn't actually collect last time. There's actually very little information on e-cigarette use in teenagers, or on water pipe use in teenagers, and I think that's going to prove to be quite interesting. So how did we do? This is our recruitment timeline, and different centres actually recruited at different times during that block. Glasgow set off but didn't complete all their numbers, which they were hoping to do, and they came back and finished off in February and March. Bristol, Oxford and London sampled most of the way through, and the other study centres came on later. And this is our recruitment by month, and you can see that nearly half our samples were actually recruited in March. So the majority of the sampling was actually undertaken between January and March this year. And this slide shows the recruitment by centre, and between January and March all the centres sampled, and we get the representative sample from across the UK during those months. But there is a number that's actually jumped off here. The number that we actually recruited in total was 21,874, which I'm really, really proud of, because our target was between 14 and 18,000. But given that we didn't actually know what the carriage rate was going to be, it's absolutely fantastic that we have those samples safely collected, and it's a real credit to each of the centres for what they are able to do. So have we realised our objectives? So we wanted to know why there was such high disease incidence and why it's reduced. And we now have tick boxes in all those 4 quadrants. We have carriage and disease isolates in high and low incidence of disease. And it will take time to analyse them, but I'm really hopeful that we will be able to answer some of those questions. The questionnaire will answer the risk factors and give an idea of the changes in behaviour of teenagers. And it will also, it's actually been quite timely, because we'll be able to use it as a baseline to evaluate the new immunisation programmes in the coming couple of years. So we'll be able to actually evaluate the impact on the meningococcal population that those vaccines has had. And there have also been a number of other related outcomes. Talks have been given in most of these schools, so not only those students that have taken part, but other students as well have been made aware of the signs and symptoms to look for and the risks of this disease as they go to university. Many other studies are going on in different centres alongside this, and I think it's absolutely fantastic that in Bristol there's a longitudinal study which uses this survey as the baseline, and they're going to follow up about 1,000 students once a month for 6 months. And so that is embedded in this national study, which is fantastic. In Glasgow, they've collected saliva as well, which they're going to use to look for salivary antibodies, and also cotinine. And that will give us an idea of the impact of passive smoking, as well as active smoking, on the carriage of meningococci. In Manchester, Jay manfully spent many hours picking numerous colonies of meningococci to look for variation, and that's going to be extremely interesting. And in Cardiff, they've been looking for the association of carriage of meningococci with some other oropharyngeal organisms. And these are going to give us a huge wealth of information and help us to really unpick what's going on. There's also been establishing links between research teams and schools and college nurses, which I think has been very valuable in those centres. And in some centres, there have been other educational opportunities. So the PI in one place also is a doctor for a rugby club, and he was asked to go back in and give a session on CPR in one college. And again, it's fantastic that this comes off the back of this particular study. And I'd just like to finish with this slide that I really quite like. This is an aspiring medical student at a public engagement day that we put on in Oxford at the Natural History Museum, and he's taking a throat swab off Gollum, who was brought along to demonstrate how we undertook the study. And so thank you once again to all the collaborators in the study. It is a fantastic group to work with. It's a really brilliant group of committed, able individuals, and to be able to stand here 8 months after the start of the study and say, yes, we did it, we got all those swabs, is fantastic. And so thank you very much.
Why was there such a big outbreak of meningococcal disease during the Second World War?
I don't exactly know the answer to that, but I think it's thought to be related to overcrowding. So when you have, it's all to do with transmission. And that's one of the reasons we looked at crowding in the first study was, I think when people are very densely, pushed together and the beds and things are very close together, that you do get transmission.